Hi, so today I'm presenting a quick introduction to 3D printing plastics. This is what I hope to cover in this video. Why would you want to 3D print? How do these magic boxes even work? How can you optimize your designs for 3D printing? And then just a general discussion about some of the potential futures for 3D printing plastics. So to answer the first question, why 3D print? The simple answer is that it allows cheap and rapid prototyping. So, imagine you design a phone stand. Congratulations, it looks great. But now you want to make 10 units of this so you can give it to people to test it. Here's a comparison of 3D printing to a more conventional method of making plastic parts. Injection molding. So for those of you who don't know, injection molding is where you melt plastic and you push it into a mold in order to make a plastic shape. This is one of the most common ways in which plastic items are mass manufactured at the moment. The quote on the left for 3D printing the stand is real. It's from 3D Hubs, but it's quite hard to get an instant quote for injection molding, but the estimates are pretty close. So as you can see, 3D printing is significantly cheaper when you're only making a few units because there's no need for a mold. In fact, the only major drawback of 3D printing is that it takes painfully long to print compared to injection molding. I should also mention that this price for 3D printing is through a service. If you were to do it yourself, this would probably cost you pennies per piece. Here's an interesting graphic from Slant 3D which just further explains the point. When you make a low quantity of units, like on the left-hand side of the graph, injection molding is super expensive. But when you start to make tens of thousands, injection molding becomes significantly cheaper, but even then not so much less than 3D printing. So once again, the only big drawback of 3D printing is the fact that it's too slow, and that's why it's not suited for mass manufacture. So if any of you watching this video does invent a super fast 3D printer, I will literally invest my entire life savings in it. And another additional benefit of 3D printing is that when you realize your phone stand is designed wrong and you can't plug your cable in, there's virtually no cost to fix that with a 3D print. Just change the design and print it again, but with an injection mold, you could be spending thousands on repairing that mold. Right, now why you probably came here. How does 3D printing plastics even work? These are my two reliable employees, and also the two most common types of 3D printing for low-cost prototyping. I'll first start by talking about FDM, which stands for Fused Deposition Modeling. You first start with a roll of filament. PLA and ABS are the most common types, and a kilogram of this costs about £15 in the UK. Notice how it's basically a cord which has been wound around a circle multiple times. Right, so now this filament feeds into what's called the extruder, which is powered by a motor. All the extruder does is pushes filament through the system. I've wrapped a bit of masking tape around the filament just so you can see what's happening, but yeah, all the extruder does is it pushes this filament into what's called the hot end. As you may have guessed, it's super hot, 200 degrees upwards in most cases. All this does is it melts the filament and before it goes to the nozzle. So what comes out of the nozzle is hot plastic. So once again, to talk it through from the top, you got your filament, the extruder pushes the filament through to the hot end, which heats it, and then you've got a nozzle. Finally, you've got servos for X, Y, and Z axes. So basically, this controls the fine movement of the nozzle in 3D space. So how I like to think of it is like a hot glue gun, but with very accurate and automated control. And yeah, so 3D prints are just done layer by layer. Now, how do the people watching this video actually get involved in 3D printing? So if you don't have a 3D printer, the process is fairly simple. Pretty much any CAD platform will do. You just need to be able to save your design as an STL. So SolidWorks, Rhino, they should all do that. And then a 3D print service will get that printed and delivered to you as easy as that. A little note is that CAD platforms such as SolidWorks may be easier than Rhino because they work around solids rather than surfaces. That's just something to keep in mind, but 3D printing is possible on both of those platforms. If you own a 3D printer, there's an extra intermediate step. So you may have heard of the concept of CAD-CAM. CAD stands for computer aided design. That's where you make the design itself. Then you got CAM, which is computer aided manufacture, which is how you program the machine to actually produce your design. In the case of 3D printing, CAM is known as slicing, and one of the most popular softwares for slicing is Cura. So Cura takes your 3D design and creates a set of instructions which your 3D printer understands to produce your design, and this set of instructions is called G-code. Right, here's a super short excerpt of a G-code file. Don't be scared. Take a look at the first line. It tells the printer exactly where the nozzle has to be in terms of X, Y, and how much material it should push on the extruder. And that's all G-code is. It's just a massive collection of instructions like this. Okay, so now a little bit about designing for 3D printing. As you can see here on the left, this 3D print has gone wrong. I've noted the direction of printing, so the bed would be at the bottom of that arrow and printing upwards. So any ideas why this has gone wrong? You may have guessed it. When the printer started printing the top of the T, it has nothing, the filament has nothing to rest on. It's just basically printing in midair. And this is an example of an overhang. Fortunately, the solution to this is simple. It's something called support material, and this goes from the bed upwards and basically gives a foundation for the filament to rest on, and this can be snapped off after printing. But where possible, you want to try and avoid this because first of all, it wastes material, and secondly, snapping material off is a bit of an inconvenience, and the surface quality there will be a little bit less. So often just reorientating the part can help a lot. So this part, if you were to just rest it flat, then you'd need zero support material. So that's something always to think about. Wall thickness. If it's too thin, it can warp or break. So 0.8 millimeters is a good guide for the minimum thickness. Infill. Because of the nature of how a 3D printer works, say you print a solid cube, the inside doesn't actually have to be fully solid. You can have a mesh instead. It does depend on the situation, but I often print with 15% infill. So the inside of my prints are 85% air, and they're pretty stiff. So this is fantastic for making light parts and saving material too. Now, print direction. This is quite important for strength. So the basic idea is that strength between layers on a print are not too strong. So on the diagram on the left, if you apply a force perpendicular to the layers, so in a way that you pull the layers apart, that's where the part is weakest. Whereas on the right, if you pull parallel to the layers, this is where the part's strongest. So think about that. Nozzle size is key, in my opinion, because with 3D printing, it's often, this type of technology at least, it's often a trade-off between speed and quality. So you can have a fast speed with low quality, and one way of achieving this is by using a wider nozzle. So if you look at these two prints here, the print on the right has been printed 5 times faster because it's using a bigger nozzle. But you can see the impact it has on quality. You can clearly see the layer lines. I should also note that using a larger nozzle does lead to stronger prints. Alright, a few misconceptions. Misconception 0 is that 3D printers can't make complex parts. I hope this slide in itself disproves that. But yeah, misconception 1, price equals quality. What do you think is the most... So these two models have been printed on 2 different printers. Which printer do you think is most expensive? If you said the left one is most expensive, you are right. But the interesting thing is the print on the left is from a £5,000 printer, whilst the print on the right is from a £200 printer. And in all honesty, this is just down to the examples I found, but I reckon with some tinkering, you could have virtually indistinguishable results. So for your extra money, what are you actually getting then by buying a £5,000 printer? You have a bigger build volume sometimes, not always. But other stuff, you can have a greater range of compatible materials and easy and quicker maintenance and less frequent maintenance. So those are the sort of things you are paying extra for. Misconception 2, 3D prints aren't strong. So this hook is about the size, well, a little bit bigger than a AA battery, and it can take up to 35 kilograms. So that's pretty strong. And I guess the point I'm trying to make there is that 3D printing can definitely be used for functional prototypes. Okay, so that's a little bit about FDM, but now let's talk about the other big technology in this market, SLA. So the previous technology of 3D printing used solid filament as its main material source, but this technology, SLA, instead uses this, which is UV resin. Now, the interesting thing about UV resin is that it's a liquid, which turns into a solid when it's exposed to UV light. I repeat that because it's really important. It's the basis of how this technology works. Rather than a solid filament, you have a liquid resin, which turns solid when exposed to UV light. This is a really difficult concept to explain, but I'll try my hardest. You'll have to use your imagination a bit here. But what you see on the screen here, this blue box, is an actual part of a 3D printer called a vat. Now this vat, it's made of aluminium, but the base of it has a transparent film. And imagine if you were to fill this blue box up with some resin, and imagine that my wood floor is actually a very strong UV light. So the UV light, it can only sort of access the resin in that circle cutout. So the UV light can only get through that circle cutout and only touch the resin there. So over time, you will lead to a 2D circle being formed. But in reality, this might be a surprise to you, but 3D printers don't actually use cut out pieces of paper. Instead, you have a high resolution display between the UV lamp and the vat. So on this display, this is what you'd show to get the circle. So that explains how you make a 2D shapes. How is 3D shapes made? It's basically the same thing, but you have a moving platform which does it, moves up a bit, moves up a bit. So just to visualize, say, this T shape again, this is how you would maybe go about making this T shape. You'd have the square for 30 seconds and then a longer section for 10 seconds. Right, so now you're probably wondering why you use one technology over the other. So let me quickly talk you through it. Cost-wise, they're getting quite comparable. So FDM used to be the cheaper printer in the first place. So just to buy the printer, FDM tended to be cheaper, and to print used to also be cheaper. But now they're both very comparative. Speed-wise, once again, getting quite close, but I'd still say FDM has the edge in most situations. Detail, now this is where SLA really wins, and I'll talk a bit about that later. Convenience, I can't stress this enough, how much easier FDM is compared to SLA. So on an FDM printer, you print, you take the print off the bed, you're done. It's as simple as that. With an SLA printer, after your print's finished, you have to clean it up with alcohol and you have to expose it to some more UV light for it to get solid. And this brings you on nicely into safety and environmental impact. The resin you use is very harmful to any biological matter, so you need to wear gloves when you handle it. You need to be very careful of how you dispose it. You should wear safety specs. And then the whole thing is based around UV light, which is also dangerous as well. So you need to make sure you don't directly look into that light without the appropriate filters for your glasses. Strength of part, generally, once again, strong with FDM. SLA prints tend to be quite brittle. Choice of materials. Now here's another place that FDM really excels over SLA. You can get many, many different colors, different characteristics, such as glow in the dark, or material which changes color with heat. So in that sense, and just generally just more materials, so you can have nylon, PLA, ABS, TPU, which is a rubbery characteristic. So much more interesting than SLA, which you'd even struggle to find unique colors in. So this slide really shows you the difference between FDM and SLA when it comes to the quality of print. So on the left, it's done by FDM, and as you can see, the layer lines are really, really clear. So FDM, the quality of the print is limited by the size of the nozzle and how accurately that nozzle can move around. Whereas with SLA, you're limited by how high the resolution of the screen is. Now, what you may have noticed is that even cheap mobile phones these days have really high resolution, small screens. And this has basically let even the cheapest SLA printers have very high resolution LCDs in them. So you can get fantastically detailed prints even at quite a cheap price. And that's the main selling point for SLA. It's a complete inconvenience to use, but you get parts which look like they came out of an injection mold, basically. And that's also my personal reason for owning one. So at the moment, I'm developing Stable Spoon, which is an affordable self-stabilizing spoon for people with hand tremors. We're getting very close to needing an injection mold. So for user testing, I want to give my testers something which feels as close to the final product as it can be. So that's why I've invested in an SLA printer myself. Now, let me talk to you very briefly about some of the potential futures I see for 3D printing technology. So in the top left, prosthetics. Now, this is something which has really been revolutionized by 3D printing. So as you can imagine, prosthetics vary a lot from person to person. They're very customized things. So that means typical mass manufacture cannot be done. So you wouldn't be making millions and millions of units of one exact hand. So basically, the ability of 3D printing to make customized units really saves people thousands. And there's even charities now which 3D print hands and other prosthetics for free, which is really cool. Top right, during the first wave of the coronavirus pandemic, UK's inept government led to hospitals running out of PPE. So actually people across the country actually 3D printed masks, which I think is really, really cool. Sorry, face covers even. Bottom left is a 3D printer in space, the only one in space. And what I find really interesting about this is I'm quite big about the whole idea of decentralization of manufacture. So typically, you have a factory somewhere, and then everything's made in this factory and then shipped everywhere. But what if everyone basically had a little factory in their house, a 3D printer? And this just pushes it to the limit, having a 3D printer in space. So imagine that astronauts don't have to bring a million tools with them, thinking, what if this happens? What if this happens? Instead, they can just bring a 3D printer. And if they need a specific tool for a very specific job, they can just be sent the file and they can print it and get on with the job. And then bottom right is interesting. It's a company called Edelkrone. And this is their new business model where they basically let the customer 3D print parts of the product, basically. So I think this is a really sustainable business model. Because first of all, it's what I was talking about. You don't need to have a factory in China making everything and then shipping everything across the world, because that's quite energy intensive and wasteful. And then the customer can decide what color, what material they want. And if any part breaks, they can simply just print another one. It's a very sustainable business model, in my opinion. Anyways, I hope this video has really helped. If you have any questions, then please do let me know in the comments. It's very different to the sort of videos I usually do. So yeah, I'm excited to hear your feedback. Thank you very much.